Specific heat capacity. Specific heat capacity can be defined as the quantity of heat required to change the temperature of 1 kg of a given substance by 1 degree Celsius. The relation specific heat capacity is equal to quantity of heat over mass times change in temperature. So this is a relation that connects specific heat capacity, quantity of heat, mass, and change in temperature. It is measured in joules per kilogram per degree Celsius or joules per kilogram per Kelvin. So we can rewrite this relation to obtain amount of heat is equal to plus or minus mass times specific heat capacity times change in temperature. So the plus is when there is heat gain and the minus is when there is heat loss. So when we say that specific heat capacity of water is 4,200 joules per kilogram per degree Celsius, then we mean that it requires 4,200 joules of heat to raise the temperature of 1 kg of water by 1 degree Celsius. Latent heat is the energy required to change the state of a pure substance without change in temperature. Latent heat of fusion is the energy required to change a unit mass of a substance from solid phase to liquid phase, like melting of ice, or liquid phase to solid phase, like solidification, without a change in temperature. So the relation is that latent heat of fusion is equal to amount of heat over mass, and the SI unit is joules per kilogram. Then we can rewrite the relation as Q equal plus or minus M times L sub F. Then let us also talk about latent heat of vaporization, which is the energy required to change a unit mass of substance from liquid phase to a vapor phase, or from vapor phase to liquid phase without a change in temperature. And we can use this relation to calculate for latent heat of vaporization. L sub V is equal to Q over M, and the SI unit is joules per kilogram. Then we have this solved for Q to obtain Q equal plus or minus M times L sub V. Now let's solve some past questions on this. We have this question: an electric drill rated 400 watts is used to drill a hole in a copper of mass 400 grams in 20 seconds. Calculate the rise in temperature if all the heat produced is absorbed by the copper. Specific heat capacity of copper is equal to 400 joules per kilogram per Kelvin. So we have this question to solve. We were given certain information, certain data from the question that can help us solve this question. So let's put down this information. We have that the electric drill is rated 400 watts, which is the power. Then we are also given the specific heat capacity of copper to be equal to 400 joules per kilogram per Kelvin. So we were also given the mass as 400 grams. 400 grams, which needs to be converted to kilogram to obtain 0.4 kg. So when we convert 400 grams to kilograms, we get 0.4 kilograms. What next? You need to recall that the heat energy produced is given by E equal P times T. We were given T as 20. So we have P, which is 400 times the time, which is 20 seconds, and that will give us 8,000. It will give us 8,000. But you need to remember that the energy produced is equal to energy absorbed. So this implies that 8,000 is equal to the mass times the specific heat capacity times the change in temperature. So let's do the substitution. We're giving all this, the mass and the specific heat capacity. So let us substitute them into this equation so that we can solve for the change in temperature. So we have 8,000 to be equal to 0.4, which is the mass, times 400, which is the specific heat capacity of copper, then times the change in temperature. So this implies that change in temperature is equal to 8,000 divided by 0.4 times 400. So this means that change in temperature is equal to 50 degrees Celsius. Therefore, the correct answer is option C. A piece of metal of mass 50 grams is cooled from 80 degrees Celsius to 20 degrees Celsius. Calculate the amount of heat loss. Specific heat capacity of the material of metal is 450 joules per kilograms per Kelvin. Now we can deduce some information from the question to help us solve this question. We have the mass to be 50 grams. We can convert this to kilograms by dividing by 1,000 to get 0.05 kilograms. Then we can also calculate the change in temperature, which is given by the final temperature minus the initial temperature, and that will give us, so the final is 20 degrees Celsius and the initial is 80 degrees Celsius. So when we subtract, we obtain negative 20 degrees, negative 60 degrees Celsius as the change in temperature. So negative 60 degrees Celsius as the change in temperature. So negative sign there is telling us that there's heat loss. So we were also given the, rewrite this. We were also given the specific heat capacity. We're also given the specific heat capacity as 450 joules per kilogram per Kelvin. 450 joules per kilogram per Kelvin. So we can calculate the amount of heat loss using the formula Q is equal to mass times specific heat capacity times change in temperature. So let's plug in the values. The mass is 0.05 times the specific heat capacity, which is 450 joules per kilogram per Kelvin. Then we also have the change in temperature, which is negative 60. So like we saw, the negative there is just telling us that there is heat loss. So the amount of heat loss will now be equal to negative 1350, and this is the same as negative 1.35 times 10 exponent 3 joules. So the negative there is just telling you that there's heat loss. Therefore, the correct answer is option D. A piece of copper of mass 20 grams at a temperature of 110 degrees Celsius was dropped into a mixture of ice and water at 0 degrees Celsius. If the final steady temperature of the mixture is 0 degrees Celsius, calculate the amount of ice melted. Specific heat capacity of copper is equal to 0.4 joules per gram per Kelvin. Specific latent heat of fusion of ice is equal to 330 joules per gram. Now we have the following data from the question. We have that the initial temperature T naught is equal to 110 degrees Celsius. Then we also have the final temperature T1 to be equal to 0 degrees Celsius. Then we have the mass of copper. The mass of copper to be equal to 20 grams. Then we're given the specific heat capacity of copper C to be equal to 0.4 joules per grams per Kelvin. 0.4 joules per gram per Kelvin. Then the latent heat of ice, latent heat of fusion of ice was giving us 330 joules per gram. Okay, so now let's see how we can calculate the heat loss by the copper. So heat loss by copper is given by Q is equal to the mass times specific heat capacity of copper times the change in temperature So we know the change in temperature is still 110. So the mass is 20 grams. So this will give us the amount of heat loss by copper to be equal to 20 times 0.4 times 110. And this will be equal to 880 joules. 880 joules. Now this implies that the heat gained by ice is also equal to 880 joules. Now we know also that Q is equal to M times latent heat of fusion. So this means that M will be equal to Q over the latent heat of fusion, and that will imply that we have M to be equal to 880 over 330. 880 over 330. And this will give us 2.667, which is the same as 2.7 grams. So the amount of ice that melted was 2.7 grams. Therefore, the correct answer is option B.